After this video, you'll finally understand which gas law you need to use and how to basically pick one every single time you see a word problem. We're gonna start prepping for your final, since that's your last exam. We're almost done. I'm sure you're excited.
Yes.
This is almost over. So today we're going to focus on gas laws. The main thing that we're going to go over, so I'm not going to necessarily go into the concepts. I'm going to just focus on the math portion of this because that's really the majority of your exam. It's all math based. So I just want to teach you all the different formulas. As you already can see on the screen, there are several that you will have to know. And then just knowing like which one to use from these word problems. So first things first is this is super important before I even talk about all the different gas laws, is this one key fact. So little me saying important. Yes, this is clearly important because for every single one of these formulas that includes temperature, you have to make sure that the units are going to be in Kelvin for every single gas law. So if there isn't temperature, of course, in the gas law, don't worry about it. But for the ones that do have, temperature, like all of these, you always want to make sure that your temperature is converted first to Kelvin, or else it's going to automatically be wrong.
Okay.
Cool. So another thing is units. So still knowing, converting your different units. I know I just mentioned temperature, remembering how to actually convert from Celsius to Kelvin. So how we would do that is simply just whatever Celsius value we get, we would just add 273 and that'll give us the new conversion in Kelvin. The next thing is pressure. So we will see that maybe some answers might have like two different pressures and you're expected to at least convert it back down to one of them. They're either going to specify, what unit they want in pressure, or you kind of have to pick and just see if you want both pressures to be in atmospheres or torr or so on. So this is all the possibilities that I typically see for pressure. This is kind of based on just the most common ones. So the most common ones is just knowing that 1 atmosphere is equal to 760 torr, 1 atmosphere is equal to 760 millimeters mercury. And then the other ones I'd say aren't as common, but just in case, still something to know. But we'll go back to it. We'll do several examples. Just want to cover all of our bases here since you're starting to finally see gas laws now. Questions so far?
No, I've actually seen a little bit of this already in lab,
Perfect.
So that's good.
Okay, perfect. I'm glad. Okay, and all of the different gas laws that you'll need to know. So these are, I'd say, the main ones. You probably will go over partial pressure as well, Dalton's law of partial pressures, but this is like the main ones that we start off with for gas laws. So the first one is going to be Boyle's law, and that's really just talking about, and I'll kind of highlight here, it's basically just, referring to pressure and volume. So we don't care about temperature or moles. Those are held constant. We're specifically just looking at pressure and volume. Next, with Charles' law, that's something a little bit different where we're now comparing volume and temperature. And then the next law is just comparing pressure and temperature, Avogadro's law, volume and moles. And then the combined gas law, which I know tends to be pretty tricky because you're putting everything together. So you're comparing pressure, volume, and temperature. And the last one that's a little bit different from the other ones is the ideal gas law, which compares basically everything. So it has pressure, volume, N is our moles, R is a known gas constant that will be provided to you. Typically that's provided to you. And then temperature. So I just say this is like the main ones that I would have memorized, you have to have down to be able to answer any of these questions. So that being said, I obviously don't expect you to know them right now. So I do have a little cheat sheet on the bottom just so we can pick from which one, like what gas law we're actually using. So how I want you to start off these questions is just like we've done before, where we have our given, we write down our given and what we're finding. And by doing so, that's literally going to tell us what formula we should use. So we are said to have a 550 milliliter sample. So right then and there, I can see, okay, milliliters, that is a unit for volume. So since I know my first volume, okay, I know that's V1 is 550.0 milliliters. Next, I'm going to keep going and see, okay, a sample of nitrogen gas is warmed from, and it's giving me two different temperatures. So my first temperature is T1, so that's 77 degrees Celsius. And then my second temperature is 86 degrees Celsius, so T2. So 86 degrees Celsius. Next, it's telling me find the new volume if pressure remains constant. So by them even talking about pressure, it's irrelevant. Because it's held constant, that just means it doesn't do anything. There's no change. We don't have to worry about it. And they're not even talking about, moles. We don't have to worry about that either. The only thing that they're telling us is, well, we want to find our second volume. So I'd go back to my formulas and I'd see, well, what compares only volume and temperature? Well, it has to be this one. So volume and temperature. So I know I have to use that formula. Makes sense.
Yeah. That's not bad.
Yeah, I'd say the hardest part is just memorizing them all. It's just knowing which formula. So I wouldn't say it's, knowing which formula to use. It's really just remembering them all. Perfect. So then the next thing we want to do before we just start plugging everything in is make sure that we convert. So let's convert both of these to Kelvin. So if you were to plug it in and you wouldn't have converted anything, it would have been wrong. So let's just simply add 273 to both of these temperatures, and that's going to convert Celsius to Kelvin. So I'll do that now. So 77 plus 273. This is going to give us 350 Kelvin, and then the next one, 86 plus 273, that'll be 359 Kelvin. Next thing, I don't have to do anything with these milliliters. I can just leave that. Just know that your final answer will be in milliliters for volume. So I'm just going to plug everything in at this point. So on top, I'll have V1 we said was 550. I'll just say milliliters for now. And then temperature, we just changed this to 350 Kelvin. Next, V2 is what we're solving for. And then we've converted this one also to Kelvin. So what I'm going to start off doing is just dividing this, and then I'll handle everything else. So just dividing these two values, we're going to get 1.57, and I'm not going to round at all. I round to the very end, 571. Cool. Let me move this over. Okay. Next step is to simply get V2 by itself. So I'm going to remove this denominator by multiplying it by both sides. This would cancel, and I now have to multiply these two together. So times 359. This is 564.14, then I'll round at the end. Just a little side note as to where the units go. This would have still have been milliliters divided by Kelvin. And then our Kelvin and our Kelvin cancel, and that's why we're just left with milliliters.
Okay. I was kind of wondering.
Yeah, and then, plus you could also just think of it as, like, the volume, it has to be in milliliters. It can't be in Kelvin or, any sort of temperature unit. Then our final answer. So how many sig figs should we round to?
Ooh. I think 4, right? Because they all count.
So for this one, yes. But for temperature, there's only...
Oh, we're just looking at
2.
the temperature?
So we're looking at,
we're looking
at
at the
everything.
least one.
Yes,
Oh, yeah.
yes. Because
Okay,
it's division,
good.
yeah. But yeah, so it would have been 2. So I could actually round down and say that this is 560 milliliters, and that's our V2. That's our second volume.
Perfect.
And that's it. Cool. Since we know that this 0 does not count as significant, only these two count.
Right.
Cool. Okay. Moving on. Same sort of concept. So we're pretty much just changing the formulas. So I'm going to start off and see that this is telling me what pressure and it tells me what unit it wants for pressure. So I know I'm looking for pressure, and I specifically want this in millimeters mercury. Next, it's saying is required to compress this amount of volume. So I know liters is a type of volume. So that's V1, 196 liters and 0.0. And then of air and then atmospheres is actually pressure. So I know atmosphere's pressure, that's going to be my P1. Actually, it's going to be my P2. And I'll explain how I knew that. Into a cylinder whose volume is that. Actually, it's not. And I'll explain why. So, the reason, like, this is also important to know, like, whether it's V1, P1, so on. How I can just tell is this keyword of, right? I know that these two have to go together. So those both have to either be 1 and 1 or 2 and 2.
Oh, okay. So it's P1 then?
Then it's P1, correct.
Okay.
So that's 196, actually pressure, 1 atmosphere. 0.00 atmospheres, yeah. And then next, they're giving us a second volume. So I know that this is going to be my V2, and I'm looking for P2. And then luckily, I don't have any temperature, so I don't have to convert anything. Next, I could either decide to convert this atmospheres to millimeters mercury right now, or I can do that at the end. Really doesn't matter. It's not going to change the answer. I'm going to do it at the end, just to make it easier. So first, I have to figure out what's the formula. So what's the formula that is going to, only have volume and pressure? Well, it's this first one, right? Only volume and pressure. That's all I'm worried about. So I know that I'm using this. And if you were given all of them, that would be so easy, right?
Yeah.
I wish. And then from here, I just plug everything in. So I know that P1 we said was 1 atmosphere. B1 was 196 liters. Is equal to P2, which is what we're solving for, and V2 was 26.01, actually 0.0 liters. Next, I'm actually going to do this on, actually I can just really just multiply that. I know it's just the same thing, right? 1 times 196 is just going to give us 196.0, and I'll say this is liters times atmospheres, since these two combine. And then next, all I have to do is divide that 26 liters to both sides to find my answer. Okay, and let's see what that gives us. So 196 divided by 26. P2 is equal to 7.5384. And then remember that liters and liters would cancel, leaving us with atmospheres. And this is P2. But we're not done yet. We wanted our final answer to be in millimeters mercury, so I'm going to convert this, and then I'll deal with sig figs and all of that. So this goes back to our unit portion of this, where 1 atmosphere is equal to 760 millimeters mercury. So that's something that you just had to remember. Okay, so I'm going to actually do this and just show that that's where I took it from. I know that 1 atmosphere is equal to 760 millimeters mercury. That is my conversion factor, and I'll convert this. So 7.5384 atmospheres, multiply this by 1 atmosphere on the bottom and 760 millimeters mercury on top. Atmospheres cancel, and let's see what that gives us. So this would give us 5729.23. Just a little side note, I didn't round this part. Like, I'll actually write everything out that I had in my calculator. This was 61538. I don't want to round until the very, very end. So that's what I actually put here. So perfect. And then next, this is millimeters mercury. Last step is just to figure out our sig figs. So looking back, since everything is multiplied, what's our least amount of sig figs?
3?
Yes, so I have to round to 3 sig figs. So that being said, we're going to actually round up. So if we see here, we only want 3 sig figs. So I wouldn't just say 572 because that's different. That changes the number entirely, right? From 5,729. So I would just round this up to 30. So I look at this next number and I say, okay, 3's next. So this would be my answer. So this was P2. Questions here?
No, that's not bad. Just need to learn all of those.
Yes, that's really it. Perfect. And then the next one. So still the same sort of concept. I'm still going to start off with what's my given, what's my finding, and then figure out the formula from, what's given and what I'm finding. So it's saying a gas balloon has a volume. So right there, okay, I know I have volume. So I'm going to say I have V1 is equal to 106.0 liters. Next, that amount when the temperature is, so okay, I've got a new temperature. So T1, 45 degrees Celsius. Next I see, and the pressure is, so pressure, this one's kind of nice, literally telling me what everything is. So 740.0 millimeters mercury. And it's asking, what will its volume be at, and now it gives me a new temperature, a new pressure. So I know this is going to be a larger formula. Since I'm asked to find, what's the new volume, I'm going to solve for V2. They also give me another temperature here. So T2 is 20 degrees Celsius. And then a new pressure. So P2 is 780.0 millimeters mercury. So since I have basically kind of like duplicates of everything, right? I have two volumes, two temperatures, two pressures. I know that the only one that combines all of these is the combined gas law, which is this, right? It has everything. So that's the formula I'm going to use. So it's gas laws. I think it's just, it's really just remembering all the formulas and knowing what to plug in where. But other than that, it's not too bad. Also knowing to convert your units. So units here, the only thing we have to convert is the temperature, right? If there is temperature, you always have to change it to Kelvin. So I'm simply going to add 273 to both temperatures so I can convert this. So let's see what that gives us. At 273 plus 45 would give us 318 Kelvin, and then 20 plus, 273, that's going to be 293 Kelvin. Perfect. And next thing is really just plug everything in. Yeah. Cool. So I'm going to start off with the first pressure. It's fine that it's, as long as these two, little note, as long as these two are the same unit, you don't have to convert anything. But if this was in, let's say, atmospheres, then you would have to convert either, this one to atmosphere, like both of these top atmospheres, or both of them to millimeters mercury. They just have to be the same.
Good to know.
Cool. So V1 was 106.0 liters. And then T1 was our new value of 318 Kelvin. And I'll set this equal. I need more room. To P2, which was 780.0 millimeters mercury. V2 is what we're solving for. And then T2 is 293 Kelvin. Okay, so let's just start off with doing all the math. What I'm going to start off with is the left side. So I'm going to multiply these two together, and then I'll divide by 318. So 740 times 106. So I'll just write what it actually gives me. So that gives me 78440. I'm going to say this is millimeters mercury times liters, and then this is still divided by 318 Kelvin. So now I'm going to do this next part. So I'm going to divide those two values, and that'll be, I'm not going to do any sort of rounding. So 246 point, a lot of sixes, and I'll say 7 to 7. There we go. This just repeats. So the next, I'm going to now divide these two values just to make our lives easier. So this is, let me put the units as well. This is still millimeters mercury times liters divided by Kelvin, since that's where I get it from. I'll divide those two values. So 780 divided by 293, that gives us 2.662116041, and this is millimeters mercury divided by Kelvin. Okay, give me a second. Probably gonna remove some of this stuff just to make our lives easier. Okay, and I still have V2 here, since that's what we're solving for. Next step is to simply just divide. So that's what I'll do. I'll divide this whole entire thing over So nothing too tricky here, I'd say. It's pretty straightforward, just knowing what formula to use.
Yeah.
Cool, so let me divide that and see what we get. So 246, and that whole number. Okay, so I get, and I'm just gonna put it up here. I get V2 is 92.658, and then I'm gonna see how many sig figs we need to round to. So just looking at, I'm gonna actually look at everything that we multiplied here. So just seeing what is the smallest amount. Well, the smallest amount would have been the Kelvin, right? So 3 sig figs would be our final answer. So I'm going to round up, looking at that 5, this would have been 92.7. And then this would have been liters.
Okay, so in this instance, it was
cancels.
okay to be in liters because it gave us the initial one in liters?
Correct. And they didn't specify.
Okay.
So if they would have asked, like, oh, I want, like what is the volume in milliliters? Then we would have had to convert it after.
Okay, cool.
Perfect. All right, so this one's a tiny bit different. I would say that this is a different formula, and that's kind of why I have these gas constants, but I'll explain how this works. So once again, what's given? What are we finding? Well, we're asked to calculate the volume. So our volume. Next, they're giving us in liters. So actually, this tells us, right? This tells us that it wants the volume in liters. Next, it says given 2 moles of H2. So now I'm given moles, so I know N is 2 moles. Next, it's telling me the temperature. Luckily, that's already in Kelvin. So our temperature and our pressure. So we're given temperature, 300 Kelvin, and then we're also given pressure. So 1.25 atmospheres. Okay, well, what's the only one that allows us to, basically combine everything and it's not like duplicates of them, meaning we don't have 2 volume, 2 temperatures, and so on? Well, it's this last one, the ideal gas law. So I know that I'm going to use this. And R is actually, it should be given to you, and you're either going to see it like this top one or this bottom one. Both of them are the same. So still the same thing. One is just rounded, the other one isn't. So I'm going to use the bottom one. That's kind of the main one that I would always use, but it honestly doesn't matter. So I'll put in pressure. So P is 1.25 atmospheres. I'll put in, we actually are solving for V. And before I even continue, I realized one thing I wanted to mention. So the units for all of this is totally fine because of the gas constants units already. So if you notice the units for our R, it's already in liters, atmospheres, moles, and Kelvin. And this is kind of like when we were talking about calorimetry with the specific heat capacity, where all of the units have to align or be the same as the specific heat capacity. It's the same sort of concept here with the ideal gas law. Like you want your moles to be in, moles, right? We want that to be in moles. You want your pressure to be in atmospheres. We always want temperature to be in Kelvin, and we're going to want our volume to be in liters. And that's why all of this is totally fine. However, if we would have let's say, started with, like torr or millimeters mercury, we would have had to have converted this to atmospheres just to match the gas constant. Does that make sense?
Okay. Yes, yeah, same principle as before. It's just
yes,
a different
formula.
But yeah.
Yeah, exactly. So cool. 2 moles, and then next our gas constant. So 0.0821 liters atmospheres divided by moles Kelvin. Sorry, I used to had a student who would always think that this said molk. Just like that's what they would always say. I don't know, just reminded me of it right now.
That's funny. That sounds like something
cute.
I'd say.
It was very cute. Yeah, he was a high school student, and every time they're like, "Oh, molk." Yep, don't forget about molk. Loved it. Cool. So we have everything. We're solving for our volume, and what I'm going to start off with is the right side. So just multiplying everything and seeing what that gives us. So 2 times everything else, 0.0821. So 49.26. We'll notice that the moles and moles will cancel. Kelvin and Kelvin cancel. We're left with liters, atmospheres. And this continues. So I'll bring this down. Next step is to get volume by itself. So I'm going to divide both sides by that atmospheres. So 0.25 atmospheres. This cancels. Our atmospheres will cancel and we're going to be left with just liters. So this volume gives us 39.408 liters. Last step is how many sig figs should we round to? What do you think?
3.
Try that again. Try it again.
Oh, 1?
Yes, I know. I know.
The original? Okay.
Yeah. And it's just because, like, well, we did plug that all in, right? It's based on whatever we plugged into the actual formula. And since this is multiplication, division for sig figs, we look at the lowest amount. So it is going to be 1. So I'm actually going to round up. So it's like I want this. I'm going to round up. So this is actually 40 liters. That's it.
Okay.
Cool.
Awesome.
I feel like this is easy, right? It's not too bad.
Yeah, this is really nice compared to everything else that we've been doing.
So how do you feel now? Did this make sense? Is this clicking with you? Let me know in the comments. And of course, if you need to go rewatch another portion of this video, please do so. Remembering all of these gas laws is going to be really important.